This is an explanation of experiment 21B and 22. For 21B, what you're going to be doing is making up what we call your stock sodium hydroxide solution. The way you're going to do that is you're going to measure out about 20 milliliters of approximately 6 molar sodium hydroxide, which will be in a bottle in the lab. Put it into your 500 milliliter Erlenmeyer flask. Add about 450 milliliters of DI water to that. Mix it up, and that's what we call your stock solution. Then you're going to standardize it, which means you're going to figure out what the concentration of sodium hydroxide, the molarity of sodium hydroxide, is in that solution. To do that, you're going to fill a burette with your stock solution. And before you fill it, you want to add a couple milliliters of the sodium hydroxide stock solution, swirl the burette, coat the inside, and let it out. Drain it out. Do that about 2 or 3 times to make sure there's nothing but your stock solution in there. Then fill it up. And the way that the burettes work is the top mark is 0 milliliters. The bottom mark is either 50 or 25 milliliters. So it measures how much you've added. Then you're going to take either a beaker or a flask, tear it out. You don't need to know its mass. Add about 1 to 1.2 grams of KHP, that's potassium hydrogen phthalate, to it. Make sure that you record 3 places past the decimal, and make sure that you have at least 1 gram in there so that you have 4 sig figs. Then add about 50 milliliters of DI water to that and 3 drops of the indicator, which is phenolphthalein. And it'll be clear at that point. You're going to do this 3 times. You're going to have 3 beakers or flasks, all with slightly different amounts of KHP in them, 50 mils of DI water, and the phenolphthalein. The next thing you're going to do is titrate the solution in the beaker, the KHP, with the stock solution that's in the burette. I'll show you how to do that when we get into lab. But what you're looking for is 1 drop of your stock solution to just turn the solution from clear to pink. The first drop of stock solution that makes the solution turn pink, the volume is going to be your final volume. Volume in your burette will be your final volume. This is called the endpoint. So the volume that's left in your burette when you reach the endpoint is called the final volume. Final volume. Initial volume, the volume that you start with. Final volume, the volume that you end with. Next, the calculations for experiment 21B. The first thing you have to do is simple subtraction to find out how many milliliters of your stock solution you added. You just take your final volume minus your initial volume. Next, you can convert that to liters by dividing by 1,000 milliliters per 1 liter. Next calculation is to calculate the moles of KHP that was in your beaker or flask. And that's just the mass of KHP that you weighed out, grams of KHP, divided by the molar mass of KHP, which is given to you in your lab manual, and it's 204.22 grams per mole. That gives you moles of KHP. And you're also told that this is a 1-to-1 mole ratio in the reaction between KHP, which is an acid, and sodium hydroxide, which means that the moles at the end point, the moles of KHP that you weighed out into your beaker is equal to the moles of sodium hydroxide that you added. Finally, you're going to calculate the concentration or molarity of sodium hydroxide in your stock solution by taking the moles of sodium hydroxide you added, which you just calculated, it's equal to the moles of KHP, divided by the volume in liters of the stock solution, which you had calculated up here, final minus initial over 1,000. You're going to do this calculation for each of the 3 flat beakers or flasks that you did, and then you're going to take their average. This is what you're going to do for experiment 22A. You're going to get an unknown from Brian in a large test tube. There's going to be an unknown number on it. Please, as soon as you get that unknown, put the unknown number in your data table, and you also will put it in your conclusion. You're going to take 5 milliliters of your unknown out of this test tube using a 5 milliliter volumetric pipette. So it's going to be 3 sig figs there, 5.00 mils. Add it to a beaker or a flask. Add about 50 mils of DI and about 3 drops of the phenolphthalein indicator. And And then you're going to titrate it just like you did in experiment 21B. You're going to use the stock solution that you made in 21B. Fill the burette just like you did in 21B. Titrate to the endpoint just like you did in 21B. And remember, the volume of stock solution that you added will be your final volume minus your initial volume. For experiment 22B, it's going to be a solid unknown, which you also will get from Brian. I believe that's in a small test tube. And again, be sure to write your unknown number down. You weigh out about 0.5 grams. Make sure you put 3 places past the decimal of your unknown, solid unknown, into a beaker. Add about 50 mils of DI water, about 3 drops of phenolphthalein indicator. And just like before, like 21B and 22A, you titrate to the endpoint, again, using the stock solution that you made in experiment 21B. You're going to remember you're going to do the titration for 22A 3 times, and you're going to do the titration for 22B 3 times. Now the calculations for experiment 22A. The first thing you're going to do is, like you did in 21B, calculate, do a simple subtraction, find the volume of stock solution you added, which is just your final volume. You read from your burette minus your initial volume, read from your burette. That's going to be milliliters added. You need liters, so you divide by 1,000 milliliters per 1 liter. That'll give you liters added. Next, you're going to calculate how many moles of sodium hydroxide you added, which is just the concentration of sodium hydroxide that you calculated back in experiment 21B. You use the stock solution from there. You already calculated its concentration in moles per liter, so whatever number you got goes here, times the liters of stock solution you added, which is right from right here. And that's moles of sodium hydroxide added. And because it's a 1-to-1 mole ratio between sodium hydroxide and the acetic acid in your unknown, that's equal to the moles of acetic acid that was in your 5 milliliters of your unknown. Finally, you're going to calculate the concentration of acetic acid in your unknown, and that's just going to be equal to the moles of acetic acid, which you got up here, because it's equal to the moles of sodium hydroxide you added, divided by the volume of the solution. And because you always had 5 milliliters of your unknown, the volume is going to be 0.00500 liters, 3 sig figs. And that'll be the concentration or molarity of your unknown, moles per liter. You're going to do this calculation, every step in this calculation 3 times, because you titrated your unknown 3 times. The calculations for experiment 22B, the first thing you're going to do is just like you did for 21B and 22A, is find the volume of stock sodium hydroxide solution you added, which is just final volume in milliliters minus the initial volume in milliliters. Then you're going to change that to liters by dividing by 1,000. Next, you calculate how many moles of sodium hydroxide you added by just taking the concentration or molarity of your stock sodium hydroxide solution. Again, you got this number in experiment 21B, times the volume of sodium hydroxide you added in liters from right here. That's moles of sodium hydroxide. And again, because it's a 1-to-1 mole ratio between sodium hydroxide and your unknown acid, that's going to be equal to the moles of unknown acid that were in your beaker. And then finally, you're going to calculate the molecular weight of your unknown just by taking the mass of unknown that you weighed out originally, get about 0.5 grams, but remember 3 places past the decimal, divided by the moles of your unknown, which you just calculated up here. And that's going to be your answer, grams per mole, your molecular weight of your unknown. Remember, you're going to do all of these calculations again 3 times because you had 3 beakers with your unknown in it. And finally, your constants in your data. There's only really one constant that you need for this lab, and that's the molecular weight of KHP, which they give you in your lab manual. It's 204.22 grams per mole. In your data table, you're going to have a place for the mass of KHP for each of the 3 trials in 21B. So 3 places for the KHP mass. All of your initial and final burette volumes. There's going to be 3 initial volumes from 21B, 3 from 22A, and 3 from 22B. And the final burette volumes, likewise 3 from 21A, 3 from 21B, 3 from 22A, and 3 from 22B. Make sure you label them so you know which is which. Also, the mass of your unknown in 22B, 3 places for that because you weighed out 3 times, and your unknown number. And that should be it.